you end up with two simple log problems. So you end up with log base, not 4, log base e of 4 is equal to x. So in exponential form, that would be e to the equals 4. And then this would be log base e of x equals 4. So e to the... So if you want, on that one, if you wanted to solve for x, did you just solve for x? Yeah, the last step that you're going to see frequently is going from logarithmic to exponential form or vice versa. Okay, back to the sheet. What about 25 through 36? You had to do this by hand because you come up with nice clean answers. Anyone there you want to talk about? Anything? Huh? 30? 30, sure. Log base 1/3 of 9? Log base 1/3 of 9. Now, do you know what that equals off the top of your head? No. So let's call it equal. What do you want to use? X. What form is that in? So let's translate it into... Can someone tell me what it is in exponential form? 1/3 to the x, yeah, equals. Now, here's something that we didn't talk about yesterday that's super important when dealing with logs and exponents. Whenever you see some certain numbers, you need to rewrite them as exponents. Things like 1/3 and 9. What is 9? What's 1/3? What happens with powers of powers? Right here. What happens with the power of a power? What do you do with them? Multiply. So what's that? 3 to the... So what does negative x equal? So x is equal to... Well done. Are there different routes you can take? Different routes you can take? Yeah. Is this a pretty clean one? I like this one. There's different ways to think about it. Just don't make simple mistakes. Sometimes you might take a slightly longer route because it's a little cleaner and easier to follow. Don't rush it. Take the extra 2-3 seconds to write out the extra step. Okay, any others from 25 through 36?
32.
32. Log base 5 of the cube root of 25. Log base 5 of the cube root of 25. Well, let's rewrite that a little bit first. What power is cube root? 1/3. So it's 25 to the what power? What can you do with the power? What are you allowed to do with powers, everybody? Do you remember? You can take powers and put them where? And put them in front. So what does this turn into? Not base 3, I'm sorry. Base 5 of 25. But do you see a number in there you want to write a little differently? What number do you see that you want to rewrite? 25, someone said? What is 25? What can you do with the 2? What can you do with the 2? Same thing. So what does it turn into? 5 of 5. What is log base 5 of 5? So what's the answer? Yeah. You could do some of those steps at the same time. Just be clear with your work. Don't skip steps. Show me what you're doing. Mainly because if you get an improper answer and there's no work, I can't give you any credit. So take your time. Are these clean answers so far? Yeah. Can they get much more disgusting? Yeah. You can make them as ugly as you want to make them. Any last questions on 1 through 36? Any last questions on 1 through 36? Can someone just tell me what's the answer to 36? Yeah. Because ln e is equal to? What is ln e? Yeah. Log base e of e is equal to? 1. Now what's a proof of that? Well, there's a few of them that you can consider proofs. Log base a of a is equal to change of base, log of a over log of a, which is 1, right? Log base a of a, you don't know what it equals? Write that into exponent form. What is it? A to the x equals a to the first. So what does that mean? X equals 1. There's several ways to go about this. And you have to realize that all of these log rules, someone asked in the last class, where do these log rules come from? Well, they kind of come from each other. For example, log of A plus log of A plus log of A. How many log of A's do you have there? 3 of them. And what can you do with the 3 in the front? A to the third. Another way to think about that, though, if I do the same exact expression, same thing. What's log A plus log A? What did I tell you have to do with exponents if you add them? Bases, what do you have to do with if you... So it's log of A what? Plus log of A. And now you multiply A and A squared, what do you get? Is that the same answer? Yeah, we use different rules to come about it. Now what about this? Log of A minus log of B. What do we know that equals? Exactly. Another way to think about that, though, this is log A plus log of B to what power? What can I do with this negative sign? To the minus 1. Right. Well, what do you do when you have plus? What do you do with the 2 things inside the log? So that's log of A times B to the negative 1. But what's that equal? So, look at that. Did we get the same thing? Using it without using that rule? Yeah. The rules are different forms of each other, essentially. There's one last quote-unquote rule or identity, or something that's just good to notice because you'll see it. You'll see this sometimes. And I'll ask you, what does that equal? And, that's a bad value. Let's say Z. Oh, that's still bad. Let's just say G, okay? Because G doesn't actually mean anything in math. Looks complicated, right? Let's say we don't know what it is. Let's call it Q. Overall, is this a log or an exponential equation? Overall. It's an exponential with a log in it, right? So this is exponential. Let's translate it into log form. Can someone tell me, raise your hand and tell me what this would be in log form? This is one thing. That's the exponent. So keep that in mind. What does this turn into? Base of Q. Yeah, and what do we know? If we know that if log A equals log B, then what? Yeah. So you know that Q is equal to, and this so, Q is equal to G. So what did we just prove? A to the log base A of X is equal to X. What has to be the same? The bases. As long as the bases are the same, what do you end up with? That. Right there. You will see that. That'll come up and you'll be like, huh? And you just need to remember, what does it collapse to? X. Got it? Sound good? Okay, ready to start with your present? What I would like you to work through on your present is by yourself. So by yourself, I'd like you to try to do, you're solving for X, 1 through 6, all by yourself. Please do that all by yourself. You could get to that point right here. What is X to the negative 2? 1 over equals 9. 9x squared is equal to 1. X squared is equal to. So X is equal to, and this is what you got over there, right? Plus or minus a third? Let's go back and actually check that answer. Let's see if it works. It could. I was thinking it might. Negative 2 log base 3, so log base 4 of 1/3 equals log base 4 of 9. Well, what's 1/3 to the negative 2? That's 9, right? That's correct. So that worked. But what about negative 2 log base 4 of negative a third? Well, what's negative 1/3 to the negative 2? It's 9. So you are correct. There are 2 answers to this. That's really cool. I did not catch that the first several thousand times I've done that problem.
When you have a negative.
No, we'll just be careful. Well, you don't. Oh, a negative power. Oh yeah, we're not. Did we talk about this yesterday? Yeah, no, it's fine. I have 3 classes and 3 different lessons for each of the 3 topics so far. Woo! A to the negative 9n is 1 over. You just flip it, yes. Does it matter what the number is?
No.
No. Does that rule change at all?
No.
Okay. Which one out of 7 through 18 looks the scariest?
Maybe
7 through 15, sorry. I didn't cut out to 18, sorry. We're going to 15, kids. 7 through 15. We'll do it in smaller than that. I'm sorry, I clipped.
12.
Which one looks really scary? 12? Okay, let's take a look at 12 as a group before I set you free-ish. Log base 4 of x plus log base 4 of x minus 3. Do we have the same base?
Yeah.
Woo! So what does that plus sign mean? Equals what? What form is that in? What? Log form. So what form should we put it in? Can someone raise their hand? I will call on them, and then you can tell me what the exponential form is. One of you? Yes?
4 to the 1
Yep.
equals x times x minus 2.
And now this is as simple as is that factorable? What?
2.
X what?
4 times
So x is equal to 4 or what?
1.
Now we have 2 answers, and I'll tell you that our algebra was correct. But what should you always do, especially on log problems? Check, check, check. Check 4. Log base 4 of 4 plus log base 4 of 4 minus 3. Well, what's log base 4 of 4? 1 plus log base 4 of 1. What's log base 4 of 1? 0. So that's 1. So that checked out. What about negative 1? There's a problem here. Log base 4 of negative 1 plus log base 4 of negative 1 minus 3. What's log base 4 of negative 1? Well, let's try to solve it. Log base 4 of negative 1, do we know what it equals? No. So what's the exponential form? Is it possible to raise 4 to a power and get out a negative number? No. This right here is undefined. So what's the only answer to this? We don't like that negative 1. The only answer is 4. So, lesson out of this one, please, 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 check your answers. Can you handle that? Can you handle that truth? Okay, let's go back here for a sec. Don't beat yourself up too much. Just do what you can, okay? Do what you can. Yes?
What about on like 23 where
Ah.
not in log
23?
Yeah.
So let's, actually we'll do last one here, 23. So it's an exponential form, so you're probably going to have to put it in. Maybe. First of all, when you see 8, what should you think? 2 to the what? 2 to the third. Raised to what power? X squared minus 2x. What's 1/2 in powers of 2? What's 1/2 in powers of 2? 2 to what power? 1. What do you do with powers of powers? Say it louder. Say it with conviction. What do you do with powers of powers? Multiply them. So what does the left side become? 2 to the what? If that's true, can someone tell me what has to be true? What kind of equation is that? Have you much experience with quadratics? Should you be able to finish that? Yeah, you should. Make it into something that you recognize. That's the moral of the story. Okay, you can keep on working on these. You're all